All right. Can you guys hear me okay? Yeah? All right. Well, as I said, my name is James Labocki. I work in the infrastructure group at Red Hat, really at the intersection of our infrastructure platforms and our management platforms. So it's a very interesting spot. I'm looking around the room. I'm amazed at how many people are here. Not that long ago, Red Hat probably didn't have this many employees as are in this room, and I think it's a real testament to how we've grown. And that's really what I want to talk about with you today is one of the different markets that Red Hat has really grown in, and that is the management space. So I want to talk to you about particularly how Red Hat can help you manage complexity in the cloud space. So this is from a CIO Insight survey, and what we see here is that 50% of costs in IT infrastructure are actually going to operating expenses. So this is pretty massive from the sense that 50 cents out of every dollar is going to just keeping the lights on. And everything we've heard in the last, in all these sessions you've been hearing, how can IT deliver more with less? And really that becomes very difficult to do when you're spending half of your money on just keeping the shop running and not innovating. So what this is leading to are really two problems. One, it's just too expensive to continue to operate this way. And number two, with all of those resources committed to operating your current infrastructure, you don't really have any time to innovate and really deliver new value to your line of business users. And the result, really, what this is a function of is the fact that there's increasing complexity in the data center today. And increasing complexity is really leading to costs in a number of different areas. So here's just a few of them. But one of them is really that you have increased downtime. And this could be a result of having multiple configurations strewn about the data center. So this might be having systems delivered differently so that they are very customized. And so it's very difficult for systems administrators to be able to scale and fix problems easily. Another one is that you may have security concerns. So if I don't have a standardized way of doing things, and I have to audit all my systems differently, it becomes very difficult to do, and it also becomes just very time-consuming. So rather than having a single place to go where I can discover all my security vulnerabilities and patch them and update them, I might have to send multiple individuals to go and do this work, which essentially drives up cost, and this also leads to what you see on the left-hand side there, these large IT staffs. So those are ways in which the cost of complexity is driving up costs, both from having to have more staff to do less, and also increasing risk through downtime. But the third one, where you see delayed provisioning down at the bottom, that's actually perhaps the biggest risk to IT organizations today. Because if IT organizations cannot deliver with the increasing expectations of the end user, then they could become irrelevant. So we see this today with the rise of the consumerization of IT and public clouds. End users, line of business users, developers are expecting to be able to get things faster. And if it takes too long to get those from enterprise IT, one of two things is going to happen. They're either going to go directly out and get that, or they're going to complain about you, right? Which I'm sure you might all be familiar with, right? So the way we deal with this increasing complexity is really in two ways. And the first way is by standardizing. So through the use of standard operating environments, you really get a more simplified infrastructure. And by having a simplified infrastructure, you can really have a bunch of benefits, which I'll go through here soon. But this will also lead to less downtime. The idea is that you get higher productivity and you reduce your costs while increasing your business agility. So what does this look like? Essentially, through the use of a systems lifecycle management tool, you could gain these capabilities on the left. You can gain a simplified and consistent infrastructure. So instead of having customized systems always developed and designed specifically for a workload, you can begin to provide common ways of doing this. You could streamline your management and administration processes, and this all happens through automation. So the benefits here are really you have a reduction in downtime, because now my administrators know what to expect when they come to a system. They don't have to look through change logs, manual change logs, and understand what's happened. You also get higher server to admin ratios, and this is going to become important as we move into this paradigm of cloud. And then finally, we get faster IT response times. So rather than waiting for a systems administrator to provision the operating system and then an application team to come in and deploy an application server and then perform security audits, we can actually deliver that in a much more streamlined fashion. So those are some of the benefits of the standard operating environment. And really, this becomes critical as we move into cloud. If you look at the lifetime of systems in a physical world, they were long-lived. So I might deploy a single system, and every 3 to 4 to 5 years, I might refresh hardware. And that was really much easier to do because I could refresh my hardware every 3 to 4 to 5 years, and then I could lay down a new operating system and manage it for the life cycle. But the number of systems in the virtual world increased, and you might have heard of virtual machine sprawl. This is commonly referred to as virtual machine sprawl, and that number of systems has increased. But in the cloud world, we're actually talking about being able to deploy hundreds, if not thousands, of instances, sometimes per day, sometimes per hour, depending on the workload. And so if we don't solve the fundamental problem of complexity through standardization and automation, we're really going to not be able to realize the benefits of cloud. Right? You can imagine if you have a 1-to-1 server admin ratio, what that will do when you move to a paradigm like cloud. So we're seeing this everywhere. In fact, this is another survey. This is a Gartner survey. And you can see that technology and politics and culture, those are all big challenges to organizations looking to build a private cloud. But far and away, the leading challenge that businesses face in the private cloud, according to this Gartner survey of many CIOs, is management and operational processes. And really, this is probably a function of the fact that in the virtual world, we had such a great reduction in capital expenditures that maybe the problem of operational and management processes was never truly solved in that world. But now that we're moving to private cloud and we're not just expecting dozens of systems provisioned a day, we're expecting hundreds and thousands of systems provisioned a day, there's really no way to ignore the problem of management and operational processes. So I just want to just real quick kind of touch on the fact that there's a difference between the workloads that you're managing in the traditional data center and the workloads you're managing in a cloud. And as Tim had mentioned in the keynote this morning, there's kind of this is kind of a continuum. So your application may exist in both of these. Your service may consist of both of these types of workloads that you're delivering to your end user. The traditional workload, of course, relies on a single large virtual machine. The virtual machine actually provides the SLA and the availability and the performance to the application. That's the big piece of the traditional workload. This is bad for a number of reasons. You don't want to tie your application directly to the virtual machine that it's running on, or rely on the infrastructure for the availability and the performance that you have, because that decreases your portability. So if I have to move my application that's sitting in a traditional workload, whether that's physical or virtual, over to another system, it's very difficult because I have to make sure specific networks with specific throughput are there. I need to make sure my storage configuration is correct. So they become less portable. Also with this model, you scale up your application. So if I need more throughput, I would add memory and CPU and network bandwidth to the virtual machine or virtual machines. Now that's the traditional workload. The cloud workload really scales out instead of up. So to add capacity, I add more instances. I keep the amount of memory and CPU and network the same across them, but I continue to add more to them. This really can tolerate failures of virtual machines. We see this with the common examples of architectures like this are Netflix, right? So they routinely take outages, and their applications are designed to take failure across whole data centers, right, and inside of Amazon. So in the cloud workload model, all the performance and availability is built into the application. It's not relying on the underlying infrastructure or the virtual machines. But it's important to note that in the data center of the future, right, in this cloud architecture, the reality is that organizations are going to have both of these. We're not just going to see everybody move to a cloud workload. There's going to be a continuum within each organization. So new applications may be written for the cloud, and traditional applications may be rewritten, or they may just stay the way they are and be managed that way. So it's important to be able to manage both of these. We can't just say we're going to move to this new paradigm of cloud and forget all the traditional workloads that we had, right? Because otherwise what we're just doing is we're just reinventing another silo inside of our organization. So that's exactly what Red Hat's management tools are aimed to do. They're aimed to evolve you to cloud, not completely change your entire data center or put new silos into it. So we recognize there's existing virtualization. Quick show of hands, how many of you are virtualized? Anybody? No? Anybody not virtualized? Probably less people, more people, okay. So there's already a large existing virtualization footprint. We recognize this. This was great because you had that giant CapEx reduction. So I buy less servers, I have less power, less cooling. What it didn't do is it didn't solve two problems. One is it didn't solve my operational problem. So I still have lots of virtual machines everywhere, and it costs me a lot of money to maintain them, right? I have a whole bunch of admins using them to maintain them. And second, it didn't actually make my IT organization look like a service to my end user. So I still have to go through the 100-step process to get my application or my service. And that's exactly what a cloud management platform solves. So a cloud management platform actually allows you to do two things. One, it allows you to more efficiently manage your existing virtualization. So you can layer this in, and suddenly you're able to get better capacity utilization metrics. You're able to right-size your virtual machines, so you can very easily determine this. And second, it allows you to expose your existing virtualization environment as a service to your end users. So now I could start to build a self-service catalog that allows my users to select the service and then use quota and workflows to then deliver that service to the end user. So that's really great, because now I've just taken my IT organization and it looks more like a service to my end user, which is what their demand is, because they're used to going to a public cloud and getting IT as a service now. So now I can do that with my internal cloud. And secondly, I'm able to start understanding my existing virtualization. So by pulling capacity utilization data and performance data out of that environment, I could begin to look at these workloads and I could start to determine where they really belong. Because the reality is, in virtualization, you have a choice. So by using the cloud management platform, I already start to gain a benefit of reduced operational expenses and increased relevance to my end user. But now I can add alternative virtualization. And what this allows me to do is I can begin to optimize workloads onto the platform that's best for them. This might be based on performance. So perhaps I know that Linux workloads run better on a specific hypervisor, or Windows workloads run better on a specific hypervisor. Or it might be based on cost. I may be able to get a lower cost virtualization platform, and so I can begin to optimize my workloads onto it. Maybe it's a developer that just wants to do a simple research project. There's no need to put him on expensive fiber channel disk. No need to put him on a virtualization provider that is very costly. We could begin to do that. So those are really for your traditional applications. So your traditional applications can live in this heterogeneous data center virtualization environment. All the while, to the end user, their experience doesn't change. They're going to the same catalog and deploying their workload, and you're deciding where that workload lives, which is very, very important. Second, after this, what we're seeing is a lot of organizations are looking at deploying an OpenStack-based private cloud. So while traditional data center virtualization and alternative virtualization provide a great platform for your traditional applications, cloud-enabled applications require greater scalability than is provided by data center virtualization. And so that's really what the private infrastructure as a service cloud, the OpenStack platform, is for. So this allows me to reduce the cost of my infrastructure because I no longer need expensive storage frames, expensive network gear. I can actually begin to do everything in software and use commodity hardware. And secondly, I get more scalability. Right? So now I am able to run my traditional applications and my cloud-enabled applications on the platform that's right. And finally, what we see is, and this really forms the basis of the private cloud. And finally, what we see is users that want to begin to leverage the public cloud. So perhaps I have, again, research and development that I want to do in the public cloud, or I have workloads that don't have sensitive customer data. I can begin to move those out, and I can plug a public cloud provider into my cloud management platform as well. So this is great for traditional and cloud-based applications. Again, this all depends on what the workload is, what the workload type is. So this really forms the basis of the hybrid cloud. The big takeaway here is that to the end user, the experience doesn't change. They are able to go to the cloud management platform and request their service. It gets delivered in an automated fashion. And really, the cloud management platform can do this using metadata and smart tagging, which I'll touch on in a little bit. But also, very importantly, is it begins to change behavior in the organization. Because with the chargeback and capacity and utilization data that you have inside the cloud management platform, you could begin to provide that information back to the end user. And now the end user can see which platforms are charging them what. And so you could begin to groom their behavior away from expensive virtualization onto alternative virtualization onto OpenStack platform. So this is really what Red Hat Cloud Infrastructure is. Red Hat Cloud Infrastructure is Red Hat CloudForms, our cloud management platform. Red Hat Enterprise Virtualization, our data center virtualization solution. And Red Hat Enterprise Linux OpenStack platform, our OpenStack private cloud. Red Hat Cloud Infrastructure is a 2-socket subscription you can purchase and choose what you want to run on the bare metal. Some of the things that you should know is that a lot of individuals come in this a different way. So there's many different ways to come to this architecture. Some users are already running Red Hat Enterprise Virtualization with CloudForms on top of it. But a large majority of the Red Hat CloudForms customers are actually running on VMware today. So Tim had spoken about the ManageIQ community. Red Hat actually acquired ManageIQ towards the end of 2012. And this was, I think, over a $100 million acquisition. When we acquired ManageIQ, we released Red Hat CloudForms, which was based on ManageIQ. And then, true to Red Hat's open source nature, we began pouring through the ManageIQ code. The two great things about ManageIQ were they were 5 years old, so they were a mature platform, and at the same time they were based on a modern application framework. So it's completely written in Ruby on Rails. It leverages a Postgres database. It's right now on RHEL 6, moving to RHEL 7, and it's actually deployed as a virtual appliance. So this means that users can very quickly take a virtual appliance, whether it's an OVA for VMware vSphere or an OVA for Red Hat Enterprise Virtualization, and within minutes they can deploy this appliance into their environment. Now normally, when you deploy an appliance, you think this isn't really a production deployment, but the way that CloudForms is designed is that it's actually designed to scale horizontally and federate. So I can deploy a single appliance in my VMware environment, and then I can begin to add more appliances and build out a federated architecture inside there to scale out. It also uses role-based access control and role-based functions inside of CloudForms so that I can actually specify which ones I want to work for automation, reporting, so on and so forth. So it's a very robust architecture. And we also deliver as a QCOW file for Red Hat Enterprise Linux OpenStack platform. I'd certainly invite you all, if there are any developers in the room, to go to manageiq.org. That is the open source community that we launched several months ago. And the first ManageIQ Design Summit is actually taking place in next week around the New York City area. So I don't know if anybody will be able to make it in time, but if you can't, you could certainly send your patches. We have a number of partners working with us in the space. We have from end users like AutoTrader who want to better their cloud management platform experience. They're participating in the community. We also have proprietary vendors like Serba who want to hook into their capacity utilization metrics into our cloud management platform. We have others like Booz Allen Hamilton who is using CloudForms today in customers that they are acting as a system integrator in. So they're actually leveraging our JBoss JBPM platform together with CloudForms to build massively scale out cloud management inside of customers. We also have configuration management vendors like Chef who are in the community beginning to write configuration plugins for Chef into CloudForms. So a lot of activity there. Just a quick time check here. So I won't go through all of these because I don't think I'll have enough time, but I do want to share one customer success. And this is actually one of the world's leading financial services companies. And this is a CloudForms success story. So this is a global company. They have hundreds of hosts and thousands of virtual machines. They're also in the Americas, EMEA, and APAC. And the challenge they had is what we saw in the slides I presented earlier. They had multiple data center virtualization deployments globally, and they did not have any insight into them. So they didn't know how much capacity utilization they needed to forecast, so they had difficulty forecasting demand. They also had difficulty keeping users from seeing things they shouldn't. So they really had a difficulty with role-based access control across these environments. So they would provide a user access to their existing virtualization, and they would see everything inside of it, right? Which is, as you might expect, not a good thing for a financial services company. And finally, they were just taking too long to deliver services to their end user. It took weeks and weeks and weeks. So they started with the first step, which is implementing a cloud management platform, as we had shown. And what they found is they're now able to gain visibility from a single dashboard into their distributed data center virtualization environment. And they're able to now forecast the demand. Also, what they've been able to do is see which workloads may be over allocated. So as an example, they may have, it's pretty typical that when you ask a database administrator, I come from the system administration side, so when you ask a database administrator, how much storage do you need? He always says 5 terabytes. No. But the reality is he may only be needing 1. And so you oversubscribe that system. Well, what they were able to do is basically determine all those systems that were overcommitted on memory and storage, and then begin to shrink the footprint of their existing virtualization. So they had to buy less physical equipment and buy less licenses to their existing virtualization. Then they were also able to enforce management policies. So using smart tagging inside of Red Hat CloudForms, they were able to tag their existing data center virtualization. I should note this happens without any access or any agents on the virtual machines. So I can be running inside of an existing VMware environment, Windows and Linux workloads. I can essentially deploy CloudForms. It will discover all of those virtual machines running in the environment. And no agents on those systems. It will leverage the VMware disk APIs to introspect the disks and then tag those systems. So it will discover if there's databases running on there, if there's application servers running on there, what users are on there, all this very rich information. And so they were able to use that to tag their entire environment. This wasn't a 6-week operation where you go in and have 30 consultants come in and spend the whole time in spreadsheets figuring out what's on what system. This was all dynamically discovered. And it's kept up to date in that manner too. So they were able to use the smart tagging and classification system to limit the access, and it was all done very easily instead of through very static means. And finally, the third benefit that they gained was that they reduced the amount of time to deliver services to their end user from 3 weeks to 15 minutes. So in my mind, this is probably the most important aspect of this, is being able to deliver to your end user the services they need faster. And then at the same time, be optimizing those inside of your own data center, where they will land, where they will live, and making sure they're audited and compliant. So I don't want to spend too much more time. I'd certainly be happy to share the rest of those with any of you afterwards. I do want to touch on one thing. The standard operating environment that we discussed earlier is really a notion that comes out of Red Hat Satellite. So Red Hat Satellite is Red Hat Enterprise Linux Systems Lifecycle Management solution. And I've gotten a lot of questions recently about how does Red Hat Cloud Forms relate to Red Hat Satellite? And the most direct answer is that they're complementary. So Red Hat Satellite, which is now on version 6, we actually launched that at the beginning of this month. We had a tremendous amount of interest in it and a lot of press about this. Red Hat Satellite 6 is the Red Hat Enterprise Linux Lifecycle Management solution. And so it manages everything inside the operating system. So when you have an operating system, it can update it, it can manage the configuration, it provides complete environment control for that, and software management for it. The latest version, Red Hat Enterprise Linux 6, is actually based on a collection of open source projects. Projects like Pulp and Foreman and Candlepin. And these projects have been out there for some time. It also integrates Puppet into the configuration management system. So all the existing Puppet that you may have in your environment can now flow alongside RPM packages through these environments. So Satellite really manages everything inside the operating system. Red Hat Cloud Forms manages everything outside of the operating system. So everything from discovering my VMware or my Red Hat Enterprise Virtualization or my OpenStack environments, all of the virtual machines and instances in there, and then actually taking care of everything around the virtual machine. So adding network interfaces, changing load balancer IP addresses as part of an automated deployment. So really these two tools are very complementary. In fact, we plan in the future to begin to blend these two together very nicely so that you can discover Satellite through Cloud Forms and begin to do even more advanced provisioning. So with that, hopefully this gives you a good idea. I think the call to action would be, if you have existing virtualization, look at a cloud management platform. If you have a cloud management platform, look at alternative virtualization. Hopefully this talk gives you a good idea of the next steps you can take in your environment. Again, thank you for your time, and I'd be happy to take any of your questions after. Thanks.